So welcome back again. Hopefully this pause, fit and start kind of thing isn't too disruptive. Again, we're kind of new at this. In your resources tab, if you had come to class, we would have provided this to you. However, Professor Emma has given us a packet of these. So I'm going to have this uploaded onto my resource tab for my section. Each of the instructors should be able to do the same. In this packet, I'm going to go through just briefly some of the things that you're going to be using for dimensions on how things get made and whatnot. Throughout the course of this packet, and here's even kind of the layout. So typically, this particular timber frame that we were going to be building was actually going to have what we call a bent, and we'll talk more about what is considered to be a bent for each particular lab section. So in our particular case, where we have 6 lab sections, each section would have been able to build a bent. It would get assembled from there. Because it's Steve and I that are actually doing the assembly and the building of this process, we're actually only going to build 2 bents. In each of the classes, you'll be able to take a reference from there. But getting back to the packet that I just kind of briefly showed you here, if you take a look, and you'll go through it on your own at your free time, if you turn to page 46, I've kind of taken this particular page and taken some components which I think are important, and I'll show them to you in a minute up on the whiteboard behind me so you can determine what is being covered in this particular section of that particular packet. With that being said, Steve actually pulled out a section of an older timber that has been laying around probably for the past couple of years, just to give you an idea as the timber shrinks and checks what that really does mean. So my guess is when this was purchased, it was actually a 6-inch by 6-inch post, just like we saw earlier over in the pile of stock that we're going to be working from. But if I take a look and I use my tape measure here, and I kind of lay it across and measure this particular dimension, you'll notice that that particular length is somewhat shy of what was originally 6 inches. So as the material tends to dry, it shrinks a little bit. Now earlier we talked about the lumber that we have over on the rack as being relatively green, actually very green, and over time, this is what I would consider to be a severe check in the lumber. And this is normal for wood that is being used in timber frame construction. Still structurally very sound. Some of the cracks do get some severe enough that they actually may have to do some patchwork over time. But with that being said, I'm going to kind of give you an idea. So in that packet, like I said, on page 46, we have a few terms that we want you to become accustomed to in at least the basics of timber frame industry. So I've kind of drawn up on the whiteboard behind us here what is covered in that particular page, and I'll kind of reference it relatively quickly and what the terms mean. So when you see written throughout that packet or throughout the time that we're talking about how dimensions are made or where they're coming from, we're working with a timber that, like I said, is 6-inch by 6-inch, approximately. It's actually pretty close to it, but depending if it's a little bit more, a little bit less, these dimensions would be changed. Probably not going to see too much change, but anyway, the term TW stands for tenon width. When you think of tenon, what you should be thinking of is, like I think of things in a very as a tongue. So the tenon is the piece of wood that's actually going to be cut out from the original member as a tab that is coming out of the particular member. So TW is tenon width. The tenon width is the longer portion, well, not necessarily longer, but it's this portion that is coming out from the original member or stock. TT, or tenon thickness, is the thickness of that particular tenon for that particular joint. This changes depending on what is being used or what member is being constructed or cut at any one particular time. We don't have a lot of differentiations of what we're using for dimensions, but in the timber frame industry, there's a lot of different size members, lots of different connections, and a lot of different ways that they do this. But at least for what we're looking at, these are the terms we're using. Now, TL stands for tenon length. Okay, the length of the tenon or the length of the projection of that particular tab coming out from that original member. Again, we have a 6-inch by 6-inch dimensional reference that we're using. Now these two black dots, those are actually just simulating when we go to peg this together, whether we use 2 holes or 1 hole or how that's done. We'll cover that later, but just to get an idea that this is a tenon that's in red coming out. Now, so this stock at one particular time was out to this particular length at one time, and we're going to go through that in a little bit. Again, we'll break, and Steve and I will do some work ahead of it and try to videotape it. So how do I determine what is the width of the tenon? How do you determine the thickness, or how do you determine the length of that particular member? So in your handout, it kind of gives you some values. So again, TL, refer back tenon length, thickness, and width. Okay, so as a base calculation, it's 2/3 times SW. Now SW refers to stock width. In our particular case, we have a 6-inch stock width. If it was 8 inches, this would change, or 10, or if things vary, there would be a lot of different changes. So here is a member coming down into a cross member here. It's just a simple structure. And here is this tenon kind of illustrated internally of what's happening inside the lumber, that henceforth the dashed term. So how do I determine the length of this particular tenon, or how far that tenon goes into the adjacent member? So tenon length is 2/3 times stock width. So in this particular case, 2/3 times our stock width is 6 inches, gives us a 4-inch tenon length. Okay? Tenon width, again, same calculation, 2/3 times stock width. So we take the tenon width, in this particular case, 2/3 times 6 gives us again 4 inches. Tenon length, tenon width are the same. Now the thickness of the tenon is a little bit narrower than the length or width of the tenon. So the tenon width is actually 2/3, 2/3 times 6 is 4, I'm sorry, jumping around a little bit. The tenon thickness is actually 1/3 times the stock width. So if I get to the TT is 1/3 times 6 is 4 inches. What am I doing here? 2 inches.